Okay, did everybody have a good weekend? Great, okay. All right, so we are definitely getting into the home stretch. This is the last week of the fifth 6 weeks. So next week is the final grading period of the 2018-19 school year. So definitely I really want to encourage you, please stay on top of your assignments, getting ready for assessments. If you have questions, come on in, let me help you out, because really that third 6 weeks along with the second is going to determine what your semester average is going to be. And for seniors, we can officially say today, next month, we are going to graduate. So we want to make sure that's all taken care of. Lexi. Well, like the grade for the fifth 6 weeks at a certain point, usually it's a week after, locks. They always say if a student isn't done, you can write them as incomplete. All that does is allow a student to get any missing grades taken care of within what they consider to be a reasonable amount of time. So the 6 weeks ends on Friday, and they consider a week a reasonable amount of time. So by next Friday, that is absolutely when the grades lock. Nothing else can be done to change the averages. Okay, and it's going to be a little more unusual for the seniors, because while if you include this week, we have 8 weeks of school left, but that final week, seniors are only going to be coming, say, the first 2 days, because you'll be taking your finals on those days. And then the counselors are going to have to take care and make sure to finalize all those. They got to get everything ready and squared away, because the very last day of school, the 24th, we graduate that night. So all the senior grades have to be taken care of early in the week. So typically what happens, and I'll talk to you guys about this probably in the coming weeks, probably next month, is that last week you come Monday and Tuesday. They're normal school days for you guys. That's when the seniors will take their finals. Everybody else will take their finals on the Thursday and Friday. Those are half days. But usually on Wednesday and Thursday of that last week, seniors are asked to come up and meet in, say, the main gym. Typically, it's around 10 in the morning. They'll go ahead and talk about, things that are going to be happening at graduation, when rehearsal is going to be. In fact, I'd probably be willing to bet that rehearsal is just going to be earlier that day, probably about 11 or noon on the 24th. And then you'll go ahead and, oh, no, we graduate on Friday. Or wait, is it the 25th, 24th? Is it 24th and 25th? Well, whatever that Friday is. Is it the 24th? Then it's the 24th, yeah. We graduate that night. We're the very first high school to have the, I still call it Spirit Arena, but I think it's United Supermarkets now. Is that right?
United Supermarket Arena.
Spirit Arena.
I just call it.
Yeah, I always call it Spirit Arena.
It's too much of a name.
Mm-hmm.
Did you know we're having an HEB made in Lubbock?
Oh, what?
HEB.
What's that?
Okay, so it's like a Walmart, and it's United Combined, and it's heaven on earth. It really is.
So HEB?
Yeah, and I used to call, I didn't know what it stand for, so I used to call it when I was little, like horses, no, hippos, horses, bears, because I didn't know what the acronym stood for.
Okay.
I mean, I still don't.
So HHB.
No.
HEB.
Oh, did I say it wrong?
Oh, yeah, everybody can hear you.
I mean, like, I'm not a bright child.
Oh, that's fine. That's fine.
What? I want a bucket. Yeah.
Okay. Well, we just got a Cheesecake Factory, into last year. The only thing, I've gotten some cheesecake from there, but every time I go, the waiting list is still 2 hours long, so I haven't even bothered to eat there yet. Okay. But yeah, Lubbock's growing. I mean, especially if you go out north, yeah. There's a lot of stuff out there that I hadn't seen before. But anyways. Okay, so as far as this week goes, we're going to continue talking about vectors. In fact, tomorrow you're going to have your last focus activity. That should be the fourth one. So right now you should have 3. If you are missing one, right over here in the folders by Christian, you should be able to find some extra copies. I always hopefully make plenty of extra copies. But they're officially due on Wednesday, and that will be the last grade of the 6 weeks. On Wednesday, probably about the last 10-15 minutes, we'll begin the district assessment. We'll continue that on Thursday, and then hopefully by Friday we're finishing up the first section of vectors, and we're able to move on to the next idea. We'll probably be on vectors for at least a couple of weeks, and then next week is going to be an unusual week because what's happening 2 of the days? Tuesday and Thursday, you've got the English STAR exams, English 1 and English 2. So if you have already passed your English STAR exams, or you don't need to take them, then they're going to be late start days for you guys. So you don't have to come in until, I want to say 1:30, is that correct?
Yeah.
Okay. All right. But there's only one thing. I already talked about the focus activities, but to all classes, if you have a retake, any outstanding homework, anything at all that needs to be taken care of grade-wise, has to be taken care of by Thursday morning, 8:05. Okay, the 4th. So you still have 4 days, okay, if there's anything you need. Excuse me. Because after that, I'm going to go ahead and start finalizing the grades, and we're going to go ahead and move on into that last 6 weeks, and things are going to start moving a little quicker because we're almost also getting into testing season. Okay, so any questions about what's coming up? No, no, no. All right, well, let's see. We've been talking about vectors, and that is a mathematical quantity represented by an arrow that has two things. What am I referring to? Direction and magnitude. That is absolutely right. Now, the magnitude could be anything, but for our purposes, a lot of times it'll be force, speed, distance, things of that nature. Now, we can always use a lowercase letter to represent a vector. In fact, it has to be bolded. Or we can go ahead and use an initial and a terminal point. We talked about that. What do these two bars mean on either side of a lowercase bolded letter? That's the magnitude. Here's the formula here. When you're asked to find the magnitude, that's the square root of a squared plus b squared. And the one thing we've been working with for quite a while now, at least a full week, is this, where it looks and acts like an ordered pair, but we know we're dealing with a vector because of the arrows. What do we call that? What kind of form? Starts with a C. Oh, not standard form. But remember? We call that component form. That's component form. Oh, no, that's okay. And then we went through several examples. We've gone through how to do this. And the last thing we talked about on Friday, very quickly, was how to go ahead and find a unit vector. So a unit vector is going to be exactly 1 unit long, but it's going in the same direction as the vector you start with. So why don't we go ahead and start there. Let's do another problem. So we already did that one. So let's say we're not on this problem anymore. Let's say I have another example. Let's say we have vector v is equal to, let's say 3, 4. That's the component form. Okay, 3, 4. Well, what I want to go ahead and do is apply this formula. The unit vector is going to be the component form divided by the magnitude. Now, we just talked about that. The magnitude of a vector, it's the square root of something. A squared plus b squared. Now remember, component form, the first value is a, the second one is b. We don't use x and y with this, we use a and b. A represents the horizontal, b represents, the vertical. So that's a squared plus b squared. So this is the square root of 3 squared plus 4 squared. So what's 3 squared? 9 plus 4 squared, 16. So that's the square root of 25. Now this one's pretty nice to us. The square root of 25 is 5. Okay. And if it's not a perfect square, then we can simplify it just like we did on Friday. We can reduce that. So I'm going to apply this formula. The component form was 3, 4 divided by, now the magnitude we just found was 5. Okay, so the way I'm going to complete the problem is I'm going to take both values, a and b, and I'm going to divide each of them by the magnitude that we just found. So 3 divided by 5 would be 3/5. 4 divided by 5 would be 4/5. And there we go. That would be a unit vector in the same direction as the original one. So let me kind of illustrate that for you. Let's say we have a coordinate grid here. Well, can anybody tell me if this vector v was in standard form? That means we put the initial end on the origin. What quadrant would he be in? He'd be in the first, yeah, because think of it as an ordered pair. From the origin, you've got a positive x and a positive y, right? So let's say this represents the vector here. Okay, this would be vector v. And remember, to go from the initial to the terminal, we went 3 to the right, we went 4 up. Remember how we could create a right triangle based on those? Okay. Well, what we just found, 3/5, 4/5, that's a vector that's only 1 unit long that's going in the exact same direction. Again, 3, 4 would be in the first quadrant because they're both positive. Well, what do you notice about the unit vector? Both values are what? Positive. So it's going to be in the exact same direction. Now, one thing that we didn't get to talk about on Friday, let's say this unit vector here, if I wanted to show that the magnitude was actually 1, well, this is A, this is B. Let's find the magnitude of that using the formula. The square root of a squared plus b squared. So let's see, the square root of a squared, so that would be 3/5 squared, plus b squared, 4/5 squared. Well, let's see, what would I get if I multiplied 3/5 times 3/5? 9 over 25, there we go. Remember, you'd multiply straight across. So that would be 9/25 plus, there you go, 4/5 times 4/5, 16/25. And you'll notice they already have the same denominator, so that 25 stays the same. What's 9 plus, ooh, I accidentally hit the screen. Sorry about that. What is 9 plus 16? 25. But 25 divided by 25 is 1. So see, it does have a magnitude of 1. It's the exact same direction, but it's only 1 unit long. Okay, that's what we're talking about when we say unit vector. Is everybody okay with that? Okay. Excuse me. Okay, well, a few other items that I want to go ahead and show you. I already used that for a previous problem. Now let's talk about what's known as linear combination. Okay. The standard unit vectors I equals 1, 0, and j equals 0, 1 can be used to represent any vector as a linear combination of I and j, such that v equals ai plus bj. Well, what you have to realize here is that when you see something in linear combination, all you have to do is use the coefficients to figure out what the component form is. Okay. So if I were to give you something like this, let's say I give you a vector negative 3i plus 7j. Okay, well, what would that be in component form? What are my coefficients of I and j? Yeah, so, well, not 3 and 7, negative 3 and then 7. That's it. This linear combination is just another way of writing component form, but you're doing it in 1 unit horizontal vectors, and you're doing it in 1 unit vertical vectors. Okay. If I were to give you this one, if I said u is equal to, let's say, 5i minus 8j. There you go. The component form would just be 5 and negative 8. Now, it could even work in the reverse order. If I have component form, and I simply want to go ahead and write it as a linear combination, let's say I had something like 2, 4. Well, what would that be in terms of I and j?
2i plus 4j.
That's it. That's all there is to it. Okay. Now, if you actually want to go ahead and run through the math, okay, I'm going to go ahead and show you why this is. Remember, I just represents 1 horizontal unit. J represents 1 vertical unit, right? So let me show you how we're able to go from this first one, negative 3i plus 7j, to negative 3, 7. Okay, so I'm going to go ahead and say v equals negative 3i, but instead of using I, I'm going to go ahead and put in his component definition. I'm going to put in 1, 0 plus 7j, but instead of j, I'm going to put in his component definition, 0, 1. Now, this is something that we talked about the other day. How would I simplify an expression that looks like this? Yeah, Brandon says just distribute. If I have an outside number, I just multiply through. So what's negative 3 times 1? So that'd be negative 3. Negative 3 times 0 is 0. Plus 7 times 0 is 0, and 7 times 1 is 7. Now, how do I add or subtract component forms? Yeah, there you go. Just add or subtract the corresponding values. Like -3 would correspond to this 0. This 0 would correspond to this 7. So -3 plus 0 is -3. 0 plus 7 is 7. And see, that's exactly what we got. Now, that's the mathematical way that you would show that. I don't expect you to do that. I just want you to see why this is. Okay? And that's all linear combination is. It's simply another way of writing your answer. If you don't want to write it in component form, well, we have this. It's called linear combination. Right, Rhett? Right. Okay. So let's try some examples here. It says, let U be the vector with initial point 3, -5, and a terminal point -2, 4. Now, they're already giving me vector V as 2i minus 3j. So what would vector V look like as a component form? 2, -3. See, I can simply change that now. Personally, if I ever have a choice, I like to go ahead and use component form. I'm more accustomed to using component form, but if you want to work a problem with linear combination, you're still going to be able to get the same answer. The coefficients are A and B. But let's go ahead and figure out what U is going to look like. Now remember, I'm giving you an initial and you have a terminal. How can I find the component form using an initial and a terminal point? It's been a while since we've seen this. Does anybody remember how I would do it? Do I take the initial and subtract the terminal, or terminal minus initial? Terminal minus initial. There we go. If you're given an initial point and a terminal point, always want to take the terminal and subtract the initial. Okay? So to find U, vector U, I'm going to take the terminal, which is -2, 4, -2, 4, and I'm going to subtract 3, -5. Okay. Well, it's going to work the same way. You just subtract the corresponding values. And that's going to give me the component form that I'm looking for. So help me out. What's -2 minus 3? Oh, not -1. -5. There we go. So that's -5. Now here's where you want to be careful. What's 4 minus -5? There you go. Remember, when you're subtracting a negative number, that changes to addition. So that would be 9. So what would this be if I did write it as a linear combination? So -5i plus 9j. There you go. That's it. That's all linear combination is. It's just another way of writing component form. Okay. Now, let's take a look at B. That was the answer for A. Okay. Now it says, I want W by finding 2u minus 3v. Now, actually, I'm going to go ahead and show you this two different ways. 2u minus 3v. All right. Excuse me. So W is equal to 2u minus 3v. So first, let's go ahead and do this using component form. Okay. Well, U in component form was -5, 9, right? So W is going to equal 2 times -5, 9. And then I'm going to subtract 3 times V. We found its component form to be 2, -3. Yes. So just like we did a moment ago. Is everybody okay with how I set that up? 2u minus 3v? Okay. So Genevieve is absolutely right. We're going to distribute. So let's see. 2 times -5. So that would be -10. 2 times 9? 18. Now, let's go ahead and distribute the -3. So if I'm taking the -3, I'm just going to be left with a plus. What's -3 times 2? -6. -3 times -3? 9. Okay. Now, how am I going to add these two vectors? There you go. Again, just look at the corresponding values. -10 corresponds to -6. 18 corresponds to 9. So W should equal what? What's -10 plus -6? -16. 27. The only thing is, remember, it wants the answer as a linear combination. So negative 16i plus 27j. That's it. Now, like I said, we're going to go ahead and work this problem two different ways. We worked it with the component form, if we have time by the end. Okay. We'll see how much further we're going to get and if we have some time. Okay. Now, let me go ahead and work the exact same problem, but with linear combination. Let's say I work the whole thing with the form that I want. Okay, so W is still going to be 2U minus 3V. So W equals 2 times, well, what's U as a linear combination? Remember, what did we find in A? It's negative 5i plus 9j, right? Negative 5i plus 9j. Now I want to subtract 3 times v, but what is the linear combination form of v? 2i minus 3j. So what you're going to notice is the fact that I have linear combination or component changes nothing. What do you think I'm going to do here? I'm still going to distribute. So W equals 2 times negative 5i, negative 10i, 2 times 9j, plus 18j. Now let's distribute that negative 3. So that would be negative 6i plus 9j. And do you notice anything? Yeah, we can add like terms, but take a look. The coefficients you have here, aren't they the exact coefficients that we just had when we were looking at component form? Yeah. So negative 10i minus 6i, you still get negative 16i plus what? 27j. So if you're asked to give your answer in linear combination, I mean, it's really up to you. Do you like component form better, or do you like working with the linear combination? You're going to get the same answer both ways. I don't have a preference. Personally, I like component form better, but it's not going to be wrong if I have an answer in component form and you give it to me as a linear combination. If it's equivalent, it's right. Okay. Now, let's go ahead and find the unit vector of W. Okay. So W, we just found him to be this. It was negative 1627, which was also negative 16i plus 27j. Remember, they're just saying the same thing. Doesn't matter the form. Okay. But now that I want to find the unit vector of W, well, we just have to apply the formula to what I have here. We're going to take the component form and divide it by the magnitude. Okay. So really the only thing we need to calculate here is the magnitude of W. But how do I find the magnitude of a vector? I keep forgetting that formula. A squared plus b squared, but we're forgetting something. Below the square root. There we go. So the square root of a squared plus b squared. And for W, there's A, there's B. Okay. So this is going to be negative 16 squared plus 27 squared. Okay. So let's go ahead and simplify this because I believe I left this as a radical. Let's see what I put here. Okay. So if you go ahead and simplify that, because I didn't go decimal on this, you should be ending up with the square root of 985. Okay, now it's not a prime number, but it's also not going to simplify. So we're just going to leave it like that. Remember, we don't want to go decimal when you're finding a unit vector. So 16 squared plus 27 squared will give me 985. Is everybody okay with that? Well, I mean, there are going to be factors, like, for example, 5 will divide in, but there's no perfect square that divides it. And that's what we need if we were to simplify. Okay. So let's put everything we know. We know that the component form is negative 1627 over, let's go ahead and put the magnitude that we just found, the square root of 985. And what do I need to do here? Divide. The two values I have, I'm going to divide by that magnitude. So I'm going to go ahead and say this is negative 16 over the square root of 985, comma, 27 over the square root 985. Now, what do I have to do here that I didn't do on the previous one? We want to go ahead and rationalize it. Okay. So what would the first value look like if I multiplied both parts by square root of 985? So this is going to be negative 16, what? Square root 985 over 985, comma, 27 square root 985 over 985. There we go. Okay. Just like that. And that's it. That'd be the unit vector. It would go in the exact same direction. Okay. So again, let me illustrate. Okay. What quadrant would vector W be in? Not the third. Okay, Christian says second. What makes you say that? Yeah, because from the origin, see, the negative makes me go left, but the positive makes me go up. So let's say this is vector W. So I'd have to go left 16 and then up 27. Remember, the component form creates the legs of a right triangle. Okay. So what we just found here, these horrible looking fractions, it gives me a vector that goes in the exact same direction, but is only what? It's only one what? 1 unit long. That's what its magnitude is. That's it. Excuse me. Got a tickle in my throat today. All right. Any questions on what we did? Okay. All right. So I'll tell you what, I was going to go ahead and stop early today. So, Marcus, you can actually go to the bathroom right now. I did have the idea to go ahead and kind of play a heartless prank on you guys today, because today is April Fool's, but I thought, that's going to be mean. I don't want to do anything, so I'll just show you pranks instead. There we go. One thing.